Good morning, everybody. My name is Wina. Welcome to my YouTube channel. So we're going to continue with our statistics playlist. As you saw earlier, we saw a bit about normal distribution or the Gaussian distribution. And now we are going to dive into depth about this type of distribution. So first of all, we have our bell-shaped curve, like we drew earlier. It's a bit like this. Okay. Then we have our mean, which is here, right in the middle, okay, which is our mu. Okay. Now, very often you will see that whenever we calculate our standard deviation, we always say one standard deviation to the right or one standard deviation to the left. Okay, so here we're going to draw our first standard deviation. And what does this mean? I'm going to tell you. So here you get the first standard deviation, which is here it would be mu plus 1 sigma, right? Standard deviation is sigma. Here it would be mu minus 1 sigma, right? This is where we get our first standard deviation. Okay, so what does this mean? It is, so when you say mu plus 1 sigma, it basically says how far a point lies from the mean. So if you're getting a value here, for instance, let's say the mean is 30 and you're getting a standard deviation of 5. So it goes on 1, 2, 3, 4, 5. So 30 to be 35. So 35 is how far this data point lies from the mean. So it's 5 standard deviation. So 5 plus the mu, which is 30. So you get 35. I will explain to you more as we go along. So this is for our first standard deviation. Then we have, when you say 2 standard deviation to the right or 2 standard deviation to the left. What do we mean by this? So here we have another range here. Let me take another color. Let's take another color, right? So that you get better idea. So this is our second standard deviation. So here we can say mu plus 2 sigma. Here it is mu minus 2 sigma because it is to the left. Then we have our third, this is our second standard deviation, okay? And this is our second standard deviation. Second standard deviation. Then, of course, we have our third standard deviation. In our third standard deviation, we say that mu, 3 standard deviation to the right, mu plus 3 sigma, and 3 standard deviation to the left is mu minus 3 sigma. Okay, so this is our third standard deviation. Okay, now there's something else. There's something called as the empirical formula. So empirical formula or empirical rule, we say. So what is this? In the empirical rule, you have 3 percentages. Okay, you have the 60%, you have 95%, and you have 99.7%. So in this, what we mean is that the 68% is the first standard deviation. Okay, this is the first standard deviation. The second, 95%, is the second standard deviation. I'll explain to you what this means. And 99.7% is the third standard deviation. What does this mean is that, let's say you have 100 data points. Okay, you have 100 data points. So let's say that you have 100 data points. The mean for these 100 data points is 30. Okay, the mean is 30, and whenever you do some calculations, you get a value of, say, 32. Okay, so what does this mean is that all values here, all values which lies here, this represents 68% of the whole data set. So meaning that if we have 100 data points, 68 data points lies within this area. Okay, 68 data points lies within this area. This is the 60%. Then, moving on, here it says 95% of your data point, 95% of the data point lies within the second standard deviation. And moving on, .7% of the data point lies within our third standard deviation. This is our empirical formula. Okay. Now, if you want to write it in another way, we can write it like this. Empirical rule. So we say the probability of mu minus sigma x lies between mu minus sigma plus mu plus sigma represents 60%. Probability that x lies within mu minus 2 sigma and mu plus 2 sigma is 95%, and the probability that mu lies within that the x lies within mu minus 3 sigma and mu plus 3 sigma is approximately 99.7%. Okay, so this normally for examples of normally distributed data set where you get these empirical formula like I explained. You get height, you also have weight, and also the iris data set. This is very common. The sepal length, petal length, okay? Data set. Okay. So I hope you got a clue, you understand a bit about empirical formula, empirical rule, how data lies within this normal distribution, how you can view your data within this normal distribution. So I hope you understood the video. I hope you liked the video. Thank you for watching. Bye bye.